Hello everyone, my name is Hirun Munnoy. Today I will present about the innovation in unbonded post-tensioning system. Introduction. What is the unbound post-tensioning system? Unbound post-tensioning system is the system that the pre-stressing tendon will not bond with the slab and the concrete, so that the force will transfer by the anchor at the end of the member only. And to make it unbond, we have to use the epoxy, yeast, or sheeting to make it unbond and move freely along the tendon. This method is advantageous for fast construction and it is good to controlling the crack. However, there are some problems of this system. First one is hard to monitoring. Because after you're pouring concrete and the concrete is set already, the loss of pre-stress due to the creep or steel relaxation will not be found until the deflection or the concrete show that it cracked, and maybe it is too late to know that the pre-stress already lost. The second one is because pre-stressed wire and pre-stressed strand is steel material, so that they can be corroded by moisture and the environmental effect. To solve this problem, there are some innovation and research that solve this problem. First one is about the monitoring system. There is a research that use the optical fiber technology to monitor the long term of post tensioning. They use the optical fiber and combine it in the sheathing of the strand, like the left picture, and detect about the strain of the optical fiber. There are three phases in this research. First one is tensile test. This test is to know that the optical fiber stress and strain can be used in the strand trace. The next phase is monitor the sensor embedded strand in a pre-stressing bend over a period of a week. This research is to know the fluctuated of the optical fiber under the pre-stressing for a while, and it is shown that the result about the fluctuating of optical fiber is not much, so that we can use this optical fiber in the pre-stressing strand. The last phase is the fabrication and loading test of two post-tension beam specimen. First specimen is box specimen and second specimen is I-beam specimen. Box specimen is ground and unground of the tendon. This one is to show the real one and collect the data. The results show that from the experimental compared with analytical results, it is matched well for unbonded strand, as you see in the right picture. However, for bonded strand, there are some significant differences in the bonded strand, as you see in the left picture. So that the results show us about if we use this optical fiber to monitor the unbound strand in the beam or girder or slab, we will use the stress of the strand. The next problem solving is material. To solve the problem about the corrosion of the steel, so that we change the steel to other material. The famous one is CFRP. So that we have to know about the behavior of the CFRP. First one is the external post tensioning by using CFRP to increase the fractional capacity. We use the external post tensioning to increase the fractional capacity and retrofitting the beam. And the results show that the external post tensioning by using GFRP can increase the fractional capacity of the beam. However, this research must have further concern about the depth of GFRP and the ratio of strength of retrofitting. The next behavior is loss of pre-stress by using two types of tests. First one is single bending test. Second one is three continuous bending test. Single bending test is to know about the simple beam, and three continuous bending test is to know about the continuous beam. The result of this research show that the friction loss rate from the calculation by using the bending radius, deviation angle, friction coefficient, and tension pre-stress as primary variable is in good agreement with the test value. And the last research is shear behavior of beam under pre-stressing. The results show that there are two shear failure modes. What are inclined compression failure and shear compression failure of the beam, depending on shear span depth ratio. If shear span depth ratio is low, it is inclined compression failure. If it is between 1 and 2.5, it is shear compression failure. Moreover, bonded and unbonded pre-stressing CFRP have the slightly different result of the failure mode. So that after the three behavior that we know about the CFRP, this one can be used in the pre-stress member in the future. This is the reference. Thank you.